Students, today's topic is constraint satisfaction problem. So what is the goal of this problem? The CSP artificial intelligence is a type of problem, and the goal of this problem is to find values for a set of variables that satisfy the given constraint. Okay, and it consists of 3.3 items. They are variables, domains, and constraints. Variables range from x1 to xn. Domains are domains are the set of values for the variables, and they are represented by the form of d, that is d1 to dn. Constraints, set of restrictions on the variables that specify which combination of variables are allowed. So the goal of CSP is to assign value to each variable so that all constraints must be satisfied. Basic components of CSP are variable, domain, and constraint. What are the constraints? In case of addition of two numbers, the carry to the next step should be 1. It's an important constraint. Always the carry to the next step is always 1. And each character must have a unique value. Okay, each and every character should have unique values. No two characters should be equal. And digits should start from 0 to 1. That is, they should be only the single digits. The starting number should be 0. And in grip, that arithmetic problem must have only one solution, no multiple solutions. Examples of CSP are map coloring problem, N-Queen's problem, Sudoku puzzle problem, crypt arithmetic problem, etc. What is the solving techniques of CSP? Means backtracking. Backtracking is the main techniques used in CSP. Backtracking and heuristic. Okay. What is crypt arithmetic problem? Converting the readable plain text into non-readable ciphertext is the crypt arithmetic problem. So solving crypt arithmetic puzzle using constraint addition problem approaches involves defining the problem's variable, domain, and constraints, and satisfy and all constraints should be satisfied. Now go to the problem. Let us take one problem. Take one readable message. T plus go equal to out. This is the given readable message. Now we should convert this message into ciphertext. How we are converting to ciphertext means we are going to assign values to the variables provided all conditions should be satisfied. Okay. Now take the readable text. 2 plus go equal to out. Now take the unique variables in the message. First take one. First take t. T is a first time is a unique variable. O, G. And here the variable O is repeated, so ignore it. Here also O is repeated, ignore it. Now U, then again T is repeated, ignore it. So there are only four unique variables in the readable text. T, O, G, U. These are the four unique variables in the readable message. Okay. And we are going to assign the domain or set of values to these unique variables. Now the readable text are on the left side and the ciphertext on the right side. Now draw the equivalent boxes for all variables in the left side. Draw one box for T, draw one box for O. Here draw one box for G, again draw one box for O, again one draw box for O, U, T. Draw one table, the table, all unique variables are there. Now we are going to assign values to all these unique variables. What's the first constraint? First constraint is the carry should be 1, right? Always the carry should be 1. So here the carry should be 1. So 1 will be assigned to the variable O. So O becomes, the variable O becomes 1. That is, we have assigned the value 1 to the variable O. Just fill it in this table. O, the value of O is 1. And then wherever you see O here, fill the value 1. So here 1, here also 1. Here also O is there, here also O is there. Any other O is there? No. So put 1, 1 here. Okay. Now add these two values. So now t becomes 2. Yeah, now t becomes 2. If there is any t here, yes, here also one t is there. Assign 2 to this variable t. So in this table also assign 2. Okay. Now the remaining boxes are g and 8. Now see, to get carry, what value should be added to the value 2? See, 2, what value should be added to 2 so that we can get the value, and the carry should be 1. 8. If you add 8, the result will be 10. 10 means we can put 0 here, and 1 can be a carry, right? So add g to 8, the result will be 10. Put 0 here, O will be carry. So g becomes 8 and u becomes O. Now we have filled the table. All variables in the table are filled. 2, 1, 8, 0. Now if you add, you will get the value 102. 21 plus 81, if you add, we will get the value 102. It should be correct. Mathematically, it should be correct. If you add 21 plus 81, 102. So readable text is 2 plus go equal to out, and unreadable ciphertext is 21 plus 81 equal to 102. Do you understand? It's a very simple problem. Now we go to the second problem. Second one is cent plus more equal to money. Okay, so the variable, all variables should be unique. Domain is a set of digits from range from 0 to 9, and these are all constraints. Okay, and these are, we are using backtracking techniques in this problem. In this problem, we are using backtracking techniques. These are all theory and value order heuristics. Okay, these are theory. Now go to the problem. Now here the given text is send more money. This is a given readable text. We are going to send this message to our to, uh, to our friend or relative. We are going to send this message to our relative or to our friends. Okay. So send plus more equal to money. Draw the equivalent boxes for all the variables in the left side. Draw boxes for all the variables in the left side. And now draw the table also. Now what is the first constraint? Carry should be 1, right? So put carry here. So 1 will be automatically assigned to M, right? So in the table also put 1 to M. Now wherever you see, put the value 1 to M. So here also one M is there. So assign the value 1 to M. Okay. Now take this column. Take this first column. S, M, O. Out of 3 variables, 1 variable we have assigned the values. The remaining variables S and O should be, or S and O value should be assigned, right? So now take this variables in this column, S plus M plus O. Now we know the value of M. Here, what value should be assigned to S so that we can get carry 1? What value should be assigned to S so that we can get the carry 1? So if you put 9, 9 plus 1 equal to 10, so that we put 0 to the variable O and we can send the carry as 1. So S becomes 9 and O becomes, variable O becomes 0, right? See, we put 9, 9 plus 1, 10, put 0 here, send 1 as carry. The table also put S equal to 9, M 1 and O 0. Okay. Now wherever you find O, assign the value 0, assign 0 to O. Here we are find one O, right? Here also assign the value 0. Okay. Now go to the next step. Now go to the next step. Take the second column, the readable text. What is second column? E plus O plus N. This is a second column. Now take this second column and find the carry for this column. Now we have to find the carry for this one. How to find the carry? Carry always should be 1, right? So we have to work out. Set the carry. If carry is 0, now take this column and change the column into row. E plus O plus N. Take this column E O N and put it in the row wise. So E plus O plus N, right? Now add 0 to the carry. Add 0 to the row. Add 0 to the row. So 0 plus E plus O equal to N. So if you strike out 0, 0, E equal to N. If you strike out this 0, E is equal to N. E equal to N. But as per constraints, all characters should be unique. As per the constraint, all characters should be unique. No two characters should be equal, right? Here, E and N are equal. Condition is not satisfied. So 0 cannot be a carry. Okay, so 0 cannot be a carry. Now check with carry 1. Now add 1 to the row. 1 plus E plus O equal to N. Okay, so 1 plus E plus O. What's the value of O? 0. Right, so 1 plus E equal to N. So equation 1. Remember this equation. So carry 1. O becomes 0. See the differences. That is O, this is 0. So 0 can be removed. So the equation 1 plus E equal to N, or N equal to 1 plus E. Whatever may be. All are same, right? So for the column 2, 1 is the carry. Or column 2, 1 is the carry. Now go to next step. Now set the carry for column 3. Now take this column, N plus R plus E, and set the carry. If carry is 0, now add 0 with the row N plus R equal to N plus R equal to E. Remove the carry N plus R equal to E. Since the previous carry is 1, already we have said the previous carry is 1, right? So previous carry is 1, we should add 10 to E. Since previous carry is 1, what value should be added here? If it is 10 means we can put 0 here and send 1 as carry, right? So add 10 to E to get the carry. To get that carry, the value 10 should be added to E. Simple mathematics. So N plus R equal to E plus 10. Do you understand? So N can be expanded as 1 plus E, right? It's the equation. 1 plus E equal to N, right? The previous slide we have seen. 1 plus E equal to, so N can be expanded as 1 plus E. 1 plus E, this equation number 1, right? So substitute here. Substitute N by 1 plus E. So 1 plus E plus R equal to E plus 10. Now R equal to, see, now R equal to, go that side, 10 minus 1. Take out this E and E. Remove this E and E. So R equal to 10 minus 1. Remove this E and that E, right? Left side, right side, you can cancel, right? So R equal to 10 minus 1, R equal to 9. But what's the problem here is, but already the value of S is 9. We have already seen the value of, we have already assigned the value 9 to S, right? So R cannot be 9 as per the constraint. Constraint is not satisfied here. We have already assigned the value 9 to S. So R cannot be 9, right? So condition is not satisfied. So R equal to 9 and S equal to 9. But the concern is all characters should be unique. R equal to S. So cannot be, so carry cannot be 0. So now try with carry 1. Always remember the equation 1 plus E equal to N. Now add 1 to the equation 1 plus N plus R equal to E plus 10. So 1 plus 1, 2, 2 plus E plus R equal to E plus 10. Take out the E on both sides, 2 plus R equal to 10, R equal to 10 minus 2, R equal to 8. Okay. R is a unique number. Okay. So put R equal to 8 in the table. R is okay. So now we have assigned the values for the variables S, M, O and R. For the remaining variables we have to assign values. Now, so the carry for this column is N plus R plus E is 1. Step 4. Take the, now we have fill the boxes. Put R equal to 8 here. Fill the boxes. Okay, step. Now we are in step 4. Now take the last column. D plus E equal to Y. Take the last column. D plus E equal to Y. Add 10 to Y so that the carry to the column 3 is 1. Okay. If you add 10 to Y, then automatically the carry to the previous column is 1. So D plus E equal to Y plus 10. To find the value of y, now we have found y for value y. For what is the value of d and e? To find the value of d and e, add any two numbers as your wish, so that you can get a number 10 or above 10. It cannot be 5 plus 5 equal to 10 because d and e should not have the same number, right? 5. Condition will not be satisfied. We can't add 5 plus 5. So go with the higher number. Now add 5 plus 6. 5 plus 6 means you will get 11. 11 means y equal to 1, carry will be 1. Okay, but here also some problem. But we have already assigned 1 to the value m. Already we assigned the value 1 to m. So y cannot be 1. Condition is not satisfied here because we are getting 11. We are setting we are carrying one there, but everything is working. But here one is already assigned to m, so y cannot be 1. Condition is not satisfied. So now try with the two set of numbers 5 plus 7 and 6 plus 7. 5 plus 7 equal to 12, y plus 6 plus 7 equal to 13. So here y equal to 2, y equal to 3. Y cannot be 1. Here y equal to 2, y equal to 3. Here 7 is common value, but to which variable it can be assigned? 7 is common value here. To which variable 7 can be assigned? D or E. Okay, first we assign 7 to E. Okay, 7 to E. So 1 plus 7 equal to 8. 1 plus 7 equal to 8. Here problem is we have 7, 1 plus 7 equal to 8, but the number 8 is already assigned to R. For R we are already assigned the number, the value 8. So here this one is wrong. We cannot assign 7 to E. So what's the alternate one? Okay, assign 7 to the variable D. We cannot assign 7 to E, so assign the value E to D. Oh, assign 7 to D. So 7, we are assigning the value 7 to D. Okay, now by default, 7, now assign 7 to D by default. What value can be assigned to E now? Okay, what value can be assigned to E? Now, assign. Now, what value can be assigned to E? 5 or 6? E cannot be 6. E cannot be 6 because 1 plus 6 equal to 7. 1 plus 6 equal to 7. But 7 is already allotted to D. 7 is already allotted to D. So, we cannot here, we cannot assign 5 to, E cannot be 6. We cannot put 6 here because 1 plus 6 equal to 7. 7 is 1 plus 6 is 7. 7 is already allotted to D. So what value can be assigned here? So E should be 5, right? So E should be 5. 5 means 1 plus 5 equal to 6. 6 can be, 6 is okay. So why E can be assigned 5. See? So E can be assigned 5. Now all the boxes are filled with values. Now the table is filled. We have assigned values to all the variables in the table, all the unique variables in the table, right? So see the now add 9 5 6 7 1 0 8 5, we are getting 10,652. So the ciphertext is 9567 plus 1085 equal to 10652. This is a ciphertext. So now we have converted the readable text into the unreadable ciphertext. Here, if you add these two values also, we get this value. If you add these two values, we will get the value. This is also correct. So the ciphertext is correct, and this cannot be understood by others, right? Now, what is the applications of CSP? CSPs are used in many fields because they are flexible and can solve real world problems efficiently. Here are some common applications. Scheduling. They help in planning things like employee shift, flight schedules, and university timetables. They are using CSP in university timetables. The goal is to assign tasks while following rules like time limits, availability, and priorities. We are using CSV in puzzle solving. Many logic puzzles such as Sudoku, crosswords, and NQ problems can be solved using CSV. The constraints make sure that the puzzle rules are followed. Configuration problems. They help in selecting the right components for a. The constraints make sure the puzzle's rules are followed. Configuration problem. Robotics and planning. Robots use CSP to plan their movements, avoid obstacles, and complete tasks efficiently. CSVs are also used in natural language processing. In NLP, they help with tasks like breaking sentences to incorrect grammatical structures based on language rules. Benefits of CSV in AI. Standardized representation. They provide a clear and structured way to define problems using variables, possible values, and rules. Smart searching techniques like backtracking and forward checking help to reduce the time needed to find solutions. Flexibility. The same CSP methods can be used in different areas without needing expert knowledge in each field. Challenges in solving CSP. Scalability. When there are too many variables and rules, the problem becomes very complex and finding a solution can take too long. You can solve it, but it will take more time. Changing problems dynamic. In real life conditions and constraints can change over time requiring CSP solutions should be updated. Impossible or over strictly problems. Sometimes a CSP may not have a solution because the rules are too strict. In such cases, adjustments or compromises may be needed to find a acceptable solution. Thank you.